Hello everyone. In this video I'll show how to perform dynamic simulation in PSSE software, and also I'll simulate a generated tripping condition and automate the whole process using Python in PSSE. So let's get started. For the software I'm using PCC Explorer 34, which is a freeware version given by Siemens PSSE, and you can simulate up to 50 buses and show up to 150 measurements, that is output channel. There are 150 output channels in this limited freeware version. So let's get started. For firstly you have to open the SAV file. For this I'm here clicking here open, and I'm going to the folder where I have the SAV file in desktop, new folder. This is my SAV file for the simulation. And just for your information, I'm using the simplified 14 generator model of Australian power system, and as I have limitation of keeping the simulation under 50 buses and also 150 output channels, I am just using the area 5 of South Australian network, that is mainly the South Australian network. You can see there are in the bus section you can see there are mainly buses from area 5 and 2 buses from area 3. If you recall the total system, okay, let me open the system. Okay, here is my system, and you can see there's 1 2 3 4 5 6 7 8 and 9 buses from area 5 and mainly 2 buses from area 3, that is the Victoria area. And you can see in my PSSE there are 2 buses, 315 and 316. You can see in the schematic there is only 315, and for this area from bus 308 to 305 I have created just one bus to simulate the load flow from Victoria. Victoria means the section region 3, area 3, from Victoria to South Australia area 5. So I have included the 316 bus number 316, that is the Haywood interconnection, and you can see I have placed it at bus 316 I have placed a load. There's the Haywood load which is 275 kilovolt, and it has a negative power. You can see it is a negative power of 450 megawatt. That means power is flowing from area 3 to area 5 through this interconnection, that is the Haywood interconnection. Though there are 2 interconnections here, I have just used the Haywood interconnection and for the sake of this video. So as now I have the SCV data, first I have to solve the network. For solving the network I can go to power flow solution, solve, or I just can click here solve icon. For solving the method I am using solution method of full Newton Raphson. Maybe I go for do not flash start and apply automatically, and all these settings just as it is. So I'm clicking solve and close. You can see first that in down here you can see met convergence tolerances are showed. So the simulation, the power flow solution is converged and there is no errors, and you can see reached tolerance in 2 iterations, and largest mismatch is 0 megawatt. So we are good to go. Before reaching to the next section, I would request you to preserve the original SAV and DOR files. So I'm making another folder in original files and keeping these 2 in a safe folder, so that I have, okay, sorry, maybe I have cut it. So I will copy it, and this is a new folder in original, and I will paste it here, so that when I work on this SAV it doesn't get changed into something else. You'll see later in this tutorial. Now that I have solved the problem, solved the power flow of this SAV file. Okay, I have to see I have to convert the loads and generators for the system. For this I will select convert a load and generator from power flow. I'll convert both the generators and the loads for all buses and click convert. The loads and generators are converted. Then I'll select factorize admittance matrix fact from power flow, and the factorization has been done. And then I'll select solution for switching studies TYSL from the power flow menu, and I'll select just as it is. OK, and yes, reach tolerance in 1 iterations. So we now have to open the dynamic spreadsheet, the DYR file for the system, but for that we have to do certain works. You can see from the machine section there are many machines in this SAV file, but as I mentioned, in PSSE freeware version of Explorer 34 you can only use up to certain number of buses. You have mainly the PSSE freeware version don't allow you to load a large number of machines into the software. So you can see in service there are only 1 2 3 4 5 6 7 8, not this one. Okay, no, this one, 7, total 7 machines in service. And you can see from the tick marks that 501 has 2 units, ID 1 and 2. Bus number 502 has 2 machines, 1 and 2. And from this one, bus number 503 has 1 machine, ID 1. And all the other machine 2 to 6 in bus 503 are inactive, are not in service. These 2 are active, you can see from the tick marks, but these are SVC, static var compensators. So we just have to deal with this mainly we have to deal with this items, these machines. So from the DYR file, you can see from the DYR file you have to open it with Notepad. But I am using Notepad plus. Okay. After opening the Notepad, you have to delete all the inactive machines from the system, from the DYR file. So you can see in 501, bus number 501, I'm only using ID 1 and 2. Yes, so you can see 501 ID 1, ID 1, 1 and 2. So these are all included. Now what about bus number 502? Okay, in 502 I'm only using 1 and 2, not 3 and 4, so I have to delete those entries. Okay, so 502 and 503, there is 3, so I have to delete these 502, 3 and 4 up to this point, 502 and 4. Okay, if you leave a space right here, the simulation will not work, so take care of that. So for the next part, I'm only using ID 1 of bus 503, so I have to keep this, all of this, but not from here. So I have to select this 503 is up to here, 503 ID 6. I have to delete this again, no spaces should be left behind, and I have to include 507 and 509, as you can see from here. 507 and 509 is still here, so this is my modified DYR file that I opened in Notepad and edited. So I'll just click save now. Okay, save, and this is my DYR file to load. So back in PSSE, I'll now open the DYR file. This is my DYR file that was edited. So okay, it will take some time to load. Okay, so this is my dynamics data, and you can see from here the same generators, same buses are in service and are ticked here also. So when you are inside the dynamics data area, you have to make certain changes. Okay, first of all, in the you have to go to the dynamic section and click on channel setup wizard. Okay, now for listen to this very carefully, that PSSE cannot handle output channels more than 150 measurements, maximum 150 output channels. This is the window where you select which quantities do you want to measure. So if you select all of these, if you select the wind machines, the load, bus, branch, and all the systems, the PSSE will just show an error. You can see have just assigned channel 150, which is the highest channel number. So you cannot select all of these, so show multiple errors. So you have to select only a few of them, so you can select none and none. And mainly what I want to visualize in the simulation is the speed of the generators, which is directly related to the generator frequency. So I'll just select the speed for all buses and click finish. Okay, oh sorry, flow peaking. Okay, just this one, just the speed, no more tick marks. Okay, finish. Okay, this shouldn't have been a problem. Okay, let's go forward and see what happens. So maybe you just have to load the DYR file again, so I'll just close it and open the DYR file again. No. Okay, now I have to channel setup wizard, none, select deselect all of this and just select speed for all buses and finish. Okay, as you can see, as I had previously shown, selecting all the outputs, the PSSE is still thinking that we have selected all the output channels, we have occupied all the output channels, so we have to restart the whole process. So let's do that and close the PSSE, not save these. So I'll just be quick. I'll first have to open the SAV file from desktop, new folder, SAV file. I have to solve it in the solve section. Solve, it has mapped convergent tolerances. Okay, then I have to convert the loads and generators, convert, then I have to solve and factorize the admittance matrix, then solve solution for switching studies. Okay, and then I have to open the DYR file. Now I have loaded the DYR file. I'll go dynamics and channel setup wizard. I'll select as much as information as I can, the speed and all buses, finish. Okay, you can see there are no errors right now. And then I'll go for solution parameters. Okay, there here you have to set certain parameters, but the details of these parameters I'll show in a later video. You have to set the acceleration to 0.3, the tolerance level to 0.0001, which is the default value. The number of channels will be 20. The number of states will be 145. The delta del T that is pronounced 0.002. Frequency filter will be 0.008, and the rest will remain the same. And you have to check, and you have to select an output file where your output will be recorded. So you can just go to the desktop new folder where you're performing a simulation, or any other place you keep the output file, and just create a dummy name, maybe test.out, and save it and press OK. Okay, the channel output file is shown here. Okay, after that you have to go to simulation options and set relative machine angles, but this is not really necessary. You can set the machine angles relative to a machine, so that if you select it relative to a machine, you can select a generator 501. So generator 501 will be the reference for all the angles of the system, so you can just select that. Okay, and after that you have to go to simulation and start the simulation. First of all, you have to perform the initialization test. You can just run select -0.02 and select initialize, and you can, if this is shown in your output bar, initial conditions checks okay, so you're good to go. Then you can perform this, just perform the simulation up to 1 second, printw 120 times steps, and printw. You can just select this as 0 and run it. You can see the output in the output bar for up to 1 second. Okay, now it's time to apply the fault. For this simulation, you can close this window. For this simulation, I'll be doing this fault. I'll perform a fault, apply a disturbance, that is to disconnect a machine, a generator tripping condition. I'll select as the 501 generator, which is the largest disturbance possible by generator tripping. So okay and okay. Okay, so status of machine 1 is set out of service. Okay, and then we will simulate the system again up to 20 seconds maybe. Run, and you can see system has run successfully, and you can close it. After that, you can open your output file and see what kind of output have you got from the simulation. You can just click open, and open the test.out file. Here you go. If you don't see the plot tree window, you can just go to view and select the plot tree. Under the plot tree menu, the plot data menu, you can see the channel files, test files. Test is the name of your output file, and under this you can see all the speed graphs. You can just drag it here. You can 501 will show 0 because that is where that fault occurred. You can deselect it. Maybe you can deselect it. Oh, sorry, I have to open the test.out file again. Yes, if you select maybe generator 502, you can see the speed curve for this machine versus time, and that is all. But I haven't shown how to automate the whole process, so for that I will close the window, close everything, and start the whole process over again very fast. Open the SAV file, solve it. The convergence tolerances has been met. I have to convert the generator and loads, then I have to factorize the whole thing, then I have to solution for switching studies. Okay, then I have to open the DUI. Sorry, I've done a mistake, and that is okay. Let's start over again. Okay, to automate the whole process, you first have to do the IO control. Select the IO control pin and press start recording. Okay, So you have to just go to the main folder and just give a name, automate, save it, and then open the SAV file, solve it, okay, the solve has been done. Okay, then convert the loads and generators. Okay, then factorize the admission matrix, and then solution for switching studies, and then open the DYR file. Okay, go to channel setup wizard, select none, and the speed, not the voltage, not the PQ flow, and for all buses finish. Then go to solution parameters, select 250 iterations, acceleration 0.3, tolerance as it is, channel of 20, state of 145, del T of 0.002, and frequency filter for 0.008. And you can specify the channel output file, maybe another one like test2.out. Okay, then you can go to simulation options. You can set the relative machine angle relative to the machine 501. Okay, then you perform the simulation. You first initialize the system, initial conditions check. Okay, you can then run for 1 second, then you can close it. You can apply disturbance of disconnected machine. You can select generator 503 maybe for now, with the number 1 unit. Okay, then you simulate the system again for 20 seconds, run it and close it. So now you will go to IO control, and not just now, just let's open your out file. There's a test2.out. okay, and then press stop recording. Okay, let's close all the windows of the PSSE and just click open PSSE again. You can see the automate.py file here in your original folder, and you open that particular Python file. You'll see all where is the py file? Run program automation file, and you'll select that Python file, automate, and you can see all the simulations are being run, and finally the plot tree is opened. The network SAV file, the DOR file are open, but you don't have to do that anymore. All the simulation, all the dynamic analysis has been done for you, and you can see from the plot book there the test results are ready. We did the tripping action for bus 503, machine 503. So in that plot you can just see 0 here, and if you open 501 maybe, you see this curve of speed versus time for generator 501. So that will be all for this video. Thank you for watching.